Welcome to Schovia. Today, we are unpacking the random forest. If you have watched our previous video, you know that a decision tree is great. It's simple and fast. But it has a major flaw. It can be jumpy. In data science terms, we say a single tree has high variance. This means that if you change your training data even slightly, the tree's predictions can swing wildly. It's unstable. So, how do we fix it? We stop relying on one tree and we build a forest. The intuition here is the wisdom of the crowd. Imagine asking one person to guess the number of jelly beans in a jar. They may be way off. But if you ask 100 people and then average their guesses, the answer is usually shockingly accurate. A random forest does exactly this. It trains many diverse decision trees, but for this to work, the trees must be different from each other. If they're all identical, averaging them does nothing. So, how do we ensure that the trees are different? We use three secret ingredients. Ingredient number one is Bootstrap sampling. Normally, you'd give the whole data set to the model. In a random forest, we give each tree a random slice of the data. We do this by sampling with replacement. Imagine reaching into a bag of data, pulling out a row, copying it, and putting it back. You do this until you have a full sample. This means that some rows get repeated and some rows are left out entirely. Because every tree sees a slightly different view of the world, every tree grows differently. Ingredient number two is feature randomness. In a normal decision tree, at every split, the model looks at every possible feature to find the best cut. But in a random forest, we force the tree to be creative. At each node, we restrict it to looking at only a random subset of features. Maybe at one node, it can only look at age and height. In the next node, it can look at income and so on. This stops one powerful feature from dominating every single tree, ensuring we get a wide variety of perspectives. The third ingredient is known as pruning. Usually, we cut decision trees short so that they don't overfit. But in a random forest, we let them grow deep and wide. Individually, these deep trees are overfitting. They are biased and wobbly. But that's okay because we have so many of them and they're all wobbly in different ways. The errors cancel out when we average them. So, to recap, we take many trees, train them on different slices of data, and force them to look at different features. The result is a stable, reliable model that usually outperforms any single tree. In our full-length video, we talk about the hyperparameters and evaluation techniques used with a random forest model. A link to it is provided in the description. Thanks for joining us on Schovia Labs. Hit that subscribe button for more insights, and as always, stay curious.